Hi, my name is Cassie Starnes, and I'll be discussing reverse mapping using Chipper the Boston Terrier. Now, Chipper has some very unique traits that all happen to be linked. First is his extreme jumping, as well as his excessive licking, and of course, his ginormous satellite ears. Now, Chipper's parents, we are assuming, were both homozygotes, and this is what each of their genetic maps would look like. Now, Chipper gets a chromosome from each parent, as seen here. So this is his genetic map. As a heterozygous individual, through a test cross, we could determine the distance between these genes by calculating the percent of recombinance. 1% recombinant represents 1 centimorgan, and the coefficient of coincidence in this case is 0.95. Chipper's relevant chromosomes are seen here. He gets one from each parent, and these are replicated chromosomes. Now, when the homologous pair comes together during metaphase 1 of meiosis, crossing over can occur. See, for example here, these alleles may switch places, and this is called a single crossover in region 1. A single crossover in region 2 would be a switch of the E alleles, while a double crossover would be a switch between the J and E alleles. Now, these chromosomes, after crossing over, will end up in a gamete. Now, these gametes will have a new combination of genes because the dominant J, dominant L, dominant E was not from the parent, and this is known as a recombinant. These are Chipper's gamete possibilities based on his original chromosomes, and these are the type of events that they would represent. These are the relevant formulas as taken from slide 42 of the exam 2 slides, and I will be using these to find the probability of each gamete. Here is my math representing each of the different gametes, and you can see I used the relevant formulas and inserted the numbers that are relevant to Chipper's case. Something significant that I want to mention is that the probability of the specific gamete is the probability of the event multiplied by 1/2. Therefore, in the formulas, I would use the gamete probability times 2. For example, for the double crossover, I used region 1, which is 0.12, region 2, 0.18, and the coefficient of coincidence, and I multiplied that all by 1/2. So the probability of a double crossover gamete is seen here. While for the single crossover in region 1, for a double crossover event, I used the gamete probability times 2 to find the probability of a single crossover in region 1. These are my sources,